All right. Okay. Hi, everyone. Hello. Hi, everyone. So, what's going on with attendance this week? So, like the lectures, I know some people might not like, but like the lab was also very sparsely attended. And while you might not like my lectures, the labs come with grades. I do assume that the people who are actually here went to the lab as well, but the people who are watching, each lab is worth 0.5 marks, and I'm not giving them to you for free at the end of the semester. So yeah. Okay, all right. So what I want to do today is implement hopefully a whole thing. So basically, I want to do strings in C the way they're done in Python, right? So I want to be able to, for example, concatenate strings, which currently in C is not very convenient because you have to actually like take care to allocate enough memory for the new string that you're building, and you would have to do it manually. So we did kind of a function for that last time. So this time I want to do the whole thing that allows you to do concatenation, that allows you to do substrings, that allows you to look up the length of the string and do it all kind of in a way that's nicely packaged in a way that it's packaged in, for example, Python. So what you're going to do is you're going to store the pointer to the memory area where the string characters are stored. So that would be, we're storing a pointer. We're going to store the length of the string. And we're going to just automatically reallocate the pointer as necessary. So in terms of the implementation approach, so in the H file, so similarly to how we would import something in Python, in the H file, we'll put the struct that defines how everything is packaged up. And then we'll define the functions, like, for example, concatenation in a C file. And then when we compile it, hopefully that's going to happen today, but if not, then tomorrow, when we compile it, we'll compile everything together. So you'll see how that all comes together. So, all right. So this is going to be a new folder. I'll name it mystr. And what you should do, so I'll save it as mystr.h for now. So what you should do is you should also create a new folder and then open it with VS Code. And the reason is if you don't, there's going to be problems when you try to compile multiple files together. So I saved my str.h. And I'll open that folder. So that's file open folder, like this. And I'm just opening my str. Do not save. All right. So the first thing I'll do is I'll define the string structure. So I'll name it mystr. And it's going to have the string, and it's going to have the length, like this. So that I don't have to call it struct mystr every time, I'll say type def struct mystr, and that's just going to be called mystr again. So you get to do that. So again, what the type def means is anytime I say mystr, I actually mean this thing. Right? So, okay. So now I want to start defining the functions that I need in order to operate on strings. So that's going to go in mystr.c. And so what are the things that I want to do with strings? Well, the first thing I want to do is I want to create a new string, right? So like in Python, when I say something like A is whatever, I want to be able to do that in C, right? So you might say, well, can't you already do it? So like we had this kind of thing. And you might say const because the right-hand side is const. And the answer is yes, you can do this. Yes, you can do this kind of thing, but that doesn't allow me to store the length. And that will also not allow me to actually reallocate this guy, except if I do it manually and in a way that's not super convenient. So, okay. So I'll say create string. Like this. And what this is going to take is it's going to take this kind of deal, and it's going to actually make it be a valid string, right? So it's going to create this guy that's of an appropriate length, and it's going to store this. So, okay, so that's going to take a pointer to my string. And it's going to take this, and I'm also going to send it the length. Technically, you could say I don't want to send it the length. I'll just find out what the length of str is using strlen. You could do that, but that would take extra time because you would have to go to the end of str until you find the null. So I'll just give it the length. Does this have to be a pointer? Anyone? Could I just say this? So it has to be a pointer because the whole idea is I'll make a new string, right? So I have to be able to modify the contents of this string that I'm passing. Right? So that suggests that it has to be a pointer. It could also be a pointer to a pointer if I really wanted to, but it has to be at least a pointer. And the reason is that the first thing that I'll do is I'll say the length is length, like this, right? So I could, if I wanted to, so let's emphasize that this is a pointer and name it PS or something. So I could, if I wanted to, make a function that just takes a string. So that would be wrong, so I'll comment it out. So I could say something like this, and then over here, I could do this, but that would not have an effect outside the function, right? The reason is that saying something like s.length, you could do it. What it does is it modifies the local variable s. So it's analogous to saying something like length equals whatever. That would compile, but it would not have an effect outside the function. Yes.
Would you be able to do something like malloc one block and create an net and use my str type in that malloc block, and then that?
Yeah, well, so the answer is yes, and in fact, you'll see an example of something like that, but there are two issues here. So one issue is if you're already inside the function and all you have is s, the local variable, the best you can hope for is to change the contents of the local variable s. That will never have any effect outside the function, right? So now outside of here, so when you're actually creating my string, here you have options, right? So here you have to send in a pointer to the string thing, and that you could create with malloc, or it could be a local variable, so that we'll get to. So, okay, so let's finish writing this, and then we'll review. So here we're saying, okay, so the length of this PS is length. And now what I want to do is I want to say, okay, so I need to have enough space in the string in order to store this guy. So that we'll do with malloc. So I'll say PS, so let me remind myself. So this is this str. So that's going to be like this. And now I could do a loop like Copilot suggests, but why don't I just do strcpy? So the idea is that it would be called so here I'll include my str.h. So the idea is that the way it would be called if I have a main function here is something like that. So I have my strs, and then I create it like so. And well, let me just make it like anxi, and then the length would be so here, like maybe the better design is to say that the length is 6, but I allocate this +1 so that I have space for the null. Of course, it's a matter of convention. Like I could just say, you know, the length is like everything plus null, right? And the effect of this is that now s dot str, yes, points to a string anxi, and s dot length is 6, right? So the only way that I could change the contents of s is if I pass the pointer to s to this create function. And inside this create function, I go to the address where the s is stored and I modify it. Right? Remember, this is going to the address PS, right? Because that's the same as star ps.length. That's just the same. Like that's what happens when you use the arrow. Yes.
Are create functions also good for modifying a string as well? We want to just like.
Well, I mean, like in a way, what I mean by create is I have this s which doesn't have anything, and now I make it contain this. Yeah. All right. So there is a design choice that's been made here. So the design choice here is allocate string and copy str to ps_str. So that's the same kind of thing as what's going on in Python. So I'm saying don't just make it so that the address of this anxi is stored in s. Actually copy the contents to the new location. I could, in principle, instead say just ps str is str. But that would be a problem. So why would that in general be problematic? I mean, it's a little bit subtle, but like right now it would work. Later down the road, this could be problematic. Why? Anyone? Hint, it's extremely subtle.
Probably not a link problem then.
No. It's very subtle. Yes.
Is that you're going to the address of STR and changing the contents needs to string that's star.
Yes. So that's one of the things. So, but if str is a const char, won't know that we're not allowed to modify. Could crash. And you won't know after that, right? So like you have to manually keep track. Oh, like I'm not actually supposed to be sending that. For that, you'll get a warning. Also, don't know if need to free it. Right? Because if it was actually a const char star, that's a string literal, you in fact cannot free it, that will crash the program. Right? So to remind people, you must free everything that was malloced. You must not free anything that was not malloced. If you kind of do this kind of money laundering thing where you send in str and you just say, well, now it's part of my string, you don't know whether you need to free it or not. Here, what I did is I malloced it and then I copied into the malloc string. So now I know for sure I'm allowed to modify it. And I know for sure that I will need to free it. And I know that I do try to free it, it won't crash. Yes.
If we just define yes, STR equals STR, will there be any memory or no?
So as it stands, without doing anything else, it's fine. If you try to modify it, that might crash the program because you're not actually allowed to modify a const char star, even if you forgot that it's a const char star. If you try to free it, that would probably crash the program. Now, again, you might say, I'll just keep track and I'll know that I'm not supposed to free it, but that creates a problem because it might be that like the one time you'll create it the one way and the other time you'll create it the other way. And you'll have to manually keep track of which my strings you're supposed to free and which you're not supposed to free. So this is a little bit slower, of course, because you need to actually copy ANSI now to PSSTR. But once you've mallocked PSSTR and you've copied into it, it's a completely independent thing. There's no issue. So that, by the way, brings up another issue. PSSTR and STR are now different pointers, but with PSSTR equals STR, they're aliases. So you try to change one, you would change the other. Of course, you're not allowed to change STR, that would crash the program anyways. So you won't even get to the issue of there being aliases, but that's another issue. Yes.
Well, why do we need to have STR via const?
So we don't. However, it's useful to say, okay, like in this function, I'm not planning to modify the contents of str, right? And then if you try to do that, then the compiler will yell at you and the error would be caught ahead of time. We're not planning to modify the contents of str because the only thing that we're trying to do with str is to copy it over into PSSTR. Does that make sense? All right. So this is this. So since over here, we're just writing it the once, we can afford to actually do error checking as well, right? So we can say, okay, so if the SSTR was not allocated, so I'm not going to overload things and do fprintf to stdr. I'll just printf. So fprintf to stdr is like basically like telling the operating system that you're printing an error message as opposed to like the usual output, but I'll just do a printf. Exist1 is very existential. Okay, exit1. So to use exit1, you need stdlib. So, oh, that's in fact already included. So, okay. So that's create. So let's do concat. So that would be mystr. So I'll name it the destination. And that would be the source. And that's all I need. So what do I want to do here? By the way, yeah, this was not KNR notation. So just move this over here. So what do I need here? So I need to find out what's the current length. If the current length is too short, we'll make it larger. So in fact, like I'll just make it so that the length is always like this. So I'll just reallocate it right away. So I'll say, okay. So p-str needs to be reallocked so that it contains enough characters. So that's the same thing as before. Before, I mean Monday. And then we need p-dest length plus p-source length plus 1. So that's the same as Monday. So that's like that. Questions about this? So what we want to do is the same thing as cat. So that means that we want to make sure that the string at the destination now contains a pointer where there is enough space to store the length of the destination plus the length of the source. In fact, we don't need the +1 because oh, we do need the +1. Yeah, because we need the null. Yes. Okay, so we need a block of cars here, right? So I have a string like n and a string like psi. I want to stick them together and I want the +1. So how much space do I need? Well, 7 characters, right? So n and psi and 1. Size of car star is answering the question of how much space do I need in order to store the address of one character. Does that make sense? So, okay. And again, we'll check if it's null. So that would happen if realloc didn't manage to actually obtain the amount of space that's required and returned null. So I'll type along with Copilot. In this case, it seems to be doing the right thing. And now that str, p-str has enough space, I can just use strcat in order to do the actual concatenation. So why the const here? Again, kind of just to remind ourselves that I'm not supposed to be modifying the content set address PSRC. All I'm doing is I'm copying stuff over from there. Technically, you could leave it out as well. Why no const here? Well, that if you put a const here, that would not compile because you are actually potentially modifying the content set address pdest, right? So you're going and you're possibly changing that pointer. Yes.
Would we want to update the length of the destination?
Yes. Thank you. Yes.
It is better to update them for the malloc or after the malloc. So I imagine that if the malloc fails, then you can already update that might fall.
So it doesn't really matter because this length, it's not as like malloc doesn't know about this length. So, and if you, so in a way, it's more convenient to do it over here because over here, we're kind of using the old pdest length. I suppose you could update it first and then do realloc, but it doesn't matter. If realloc fails, you exit the program anyway, so you won't ever execute line 42. If you're at line 42, then clearly you did not exit the program, so realloc succeeded. But realloc directly doesn't know about the length, right? So like realloc gets this, but as far as realloc is concerned, this is like a number like any other number. Does that make sense? Okay. Is this making so okay? All right. So now that we have this, we can so I can do like another string. So maybe I'll create a string called praxis. Not like this. Maybe like this. Okay, that is 9. So now what I can do is I can concatenate stuff, right? So I can say, let's concatenate S and praxis. And now I can print the result. Like so. So let's try to compile it. All right, and it worked. Yes.
We do S dot str. How is that different than S arrow?
Arrow. Right. Right. So S arrow. So A arrow B is the same as star A dot B. Right. So if A is a pointer, so if A is an address, and it's an address of a struct, then in order to access the field of a struct, you would do A arrow B. In this case, S here and praxis here, those are not pointers, those are actually just structs. So to access the field, you would do S dot.
So the A arrow B, that's a package series.
So A arrow B, people say, is syntactic sugar for this in the sense that this just gets converted into this, right? So the difference is in here, P dest is a pointer to my string. So if I want to go and change the field string in P dest, I say P dest arrow str. And that's right. And that's because P dest is of type pointer to my string. Over here, so of course, like those are the same thing, right? So over here, S is just the variable S. So in order to access this, it would be s.str. If in main you wanted to do the arrow, what you can do is address of S str. Right? So address of S is the pointer to S. So and of course, like this, so this is kind of like so what is this? It's kind of like star address of S dot str. Absolutely not. So star kind of just cancels out the address of. Is that making sense to everyone? So that's going on all over the place, just kind of not in the same line, right? So we are sending address of S to my string cat. And then inside of my string cat, we're doing the arrow. So this is exactly what's happening. It's just like not as a one-liner. Now, the use of it is that I'm sending the address to the function so that the function can modify the contents. Here, of course, not sending anything anywhere, so don't need it. But yeah, like you could totally do that. Yes.
For the myStringCat function, you could. I'm wondering if for the source that could be like you don't have to send the address, right?
That's true. Yes. So just kind of for symmetry, I prefer to send the address, but you're completely right. I could avoid that and I could send just the actual thing. Of course, like that would break the symmetry here. So it would be kind of annoying. I would have to say dot here. I would have to say error here. That's a minor thing. Usually what you do when you send in a struct to a function is you send a pointer. And the reason is that the struct can be quite large. So if you send in the actual struct rather than the address, you need to copy the entire contents. And that could be a lot. So here actually, like my particular struct is quite small. So in fact, well, like in this case, it's quite small, but it's still larger than one pointer because in fact it contains a pointer. So it's slightly more efficient to send pointer. You do pay for it a little bit in the sense that it's like one extra step to dereference the pointer. But yeah.
It's always possible to
yes. Yes. Yeah. Like very rarely would you pass the actual thing as opposed to the pointer.
There's really no downsides besides like you are thinking about it. There's no like actual memory downsides to.
Well, I mean, like once you start saying this and that and is not a big deal, the question arises, why are you programming in C in the first place? The whole point of C is to do kind of tight optimization. But yes.
I mean, you're in syntax.
Yeah. As syntax, yeah.
But
yeah.
Like, it's not like there's limitations to passing in.
There is absolutely no limitations to passing the pointer in the sense that you can always go back and get the value. In terms of time, there can be considerations, right? So like doing star something, that's one more step that you spend time doing. Now, not a lot, but yeah.
That's as opposed to copying.
Right. So if this is large, then yeah, it becomes much less efficient. So all right. So that's like that. So now if I run Valgrind on this, is it gonna say that everything is okay? Yeah. Correct. Yes. So we allocated like no tomorrow and we never freed anything. So what can we do? So what we want to do is we want to clean up basically any string that we created, we also need to destroy. So I'll also make a destroy thing. So create and destroy are just like the common terms for that. I'm not trying to like create like violent imagery here. That's just what people say. So what do we want to do? So we'll just say, as Copilot suggests, we'll say free PSSTR. So PSSTR got malloced when we created the string over here. So here we'll just free it. This is kind of optional. So you can say that just to make sure that if I try to accidentally access a string that's destroyed, I actually want it to crash. And I want it to crash like in a very unambiguous way. It'll just say your pointer is null now. So I'll just set the pointer to null. And I'll set the length to 0.
In the definition of a struct, would it like be equivalent to write car str brackets? Say it's like an array?
No, it would not be. So if you say that str here is an array, first of all, you have to specify the size of the array, and that would be fixed. Second of all, an array already exists, so you would not need to malloc it. You would not be able to malloc it. All right, so that's like that. And now after we've used the two strings, we clean up after ourselves and we destroy this. So my str destroy takes a pointer. So again, we send the address. That is what enables us to change the value of str. And we also destroy praxis, not for another year. So okay. Or like, like if you stay in engineering, not for another 40 years. So yeah. So anyway, so okay. So that's like this. So what was the point of all this? So the point was, if I hadn't gone through all of this, I could have just used C's strcat and stuff like that. The problem is that does not do error checking for me. So if I allocate too large a string and malloc just silently returns null, I would not be able to detect it. My program would crash without printing out an error message. So here I just made sure that I can use this in a way that's kind of semi-convenient. So I can say create, I can say cat, and I don't have to do error checking every time. So why is this not implemented in C already? Well, in a way it is. Like if you want to use all of those conveniences, what it means is you're programming in Python. So what we're doing here is we're kind of implementing a small part of Python. Why not implement all of Python? Well, people have done it, and that's why there is Python. So what you're doing in C is sometimes you want this, and then you would do this. Sometimes what you want is to actually write Python. Python is, in fact, written in C. So like if you're creating a new programming language, you would do this. Often what happens is you want to do some things very efficiently, but some things maybe you want to do a thorough job of error checking, and C allows you this flexibility. So this particular code, you would see it Well, like sometimes people would implement, of course, like it's also like on GitHub all over the place. You would see this kind of code in the actual implementation of Python. So that's another use of it. Another reason that we're doing it now is just to show you an example of this is how you would implement a string. That's something that already exists, of course. But if you want to implement something that's like a string, but not quite, and it's new and doesn't exist, then you would go to C and you would do something like this. So it's kind of an example. Of course, like people have already done it. In fact, this kind of code is part of the C Python implementation already. Yes.
I think you mentioned that there's lots of value when you're writing Python, then have certain functions then written in C to speed
Yeah,
up.
yeah.
Will we cover like, just I guess like multiply number by variable? Will we cover how to do that?
Yeah, in fact, that is the plan for Friday. So yeah.
Like how to call functions written in C.
That is not Friday. Sorry, I thought you meant something else. We'll do something else exciting. So I can like maybe give you a link. I'm not planning to really do it, but yeah, like. And there's like multiple ways of doing it as well, but yeah, like no plans to do that. I might reconsider. So okay. So that's like this. So now the way it's implemented right now is not very convenient because I have my general purpose functions for strings in the same file as my main function. So in general, what you would hope is that you are able to use strings in a new program, but you don't have to copy and paste your string code every time. So the way to do this is to basically move the main, so keep my string C as just the functions that we wrote for my string. And then we'll have a separate file where we actually use it. So I'll save this as use my string. And here, what you're going to do, or the not destroy praxis. I guess I didn't. I meant to. Okay. So now we have kind of the general purpose string functions over here. I meant use, not user. And I have my use my string over here. So here I need to be able to define my string. So I'll include my string.h. So in double quotes, because my string.h is a custom header file that I made and that exists in the same folder. And I also have a printf, so I need stdio. And now when I compile this, what I need to do is I need to compile my string C and use my string C. So implicitly, my string H is kind of part of those because I said include. So I'll just quickly do a header guard here. So when I compile this thing, what I want to do is I want to compile this and this. And then both of those basically copy and paste my string.h into them. Whatever gets included first, that's when my string.h is going to be compiled. The second time when I include my string.h, nothing happens because none of this actually gets copy pasted the second time once this my string h is defined. Yes. Yes, so the question was, could you move the functions into my string H? And the answer is yes, you could, but that's considered to be like not good style. So actual code that's not definitions should go into my string.c. Unfortunately, my laptop froze. And we have, oh, it didn't freeze completely. Yeah, sorry. So like I updated it and it did not work. There is just one more. So there are two more things that are left. Oh, I'll just answer questions. Great. Yes.
Would it be more convenient to include data like let's say an SDIO in a header file instead of both files, or only including one?
Whether it would be more convenient is questionable. The reason is that if you don't include stdio.h, VS Code is not going to be smart enough to know that you've included it elsewhere, so it might give you a warning. So in that way, it might not be convenient. The other way in which it might not be convenient is you don't necessarily know in which order the C files are compiled. So if it happens that the first C file that's compiled already has included stdio.h, then that's fine. But if that's not the case, then you might also get a compilation error.
If you think we are compiling like the order we include the file name or the random.
So it's neither random nor the order in which you do. It's like it just does something. Okay. Yeah. Other questions? Yes. Right. So fbdio.h is a standard header file. It's not in the same folder as the C file that you're using. So the quotes are for the stuff that exists in the same folder, and that's a custom header function. Right? Yeah.
What is the first two lines do there?
So the first two lines, so that's the header guard from I believe last Friday. So what you want to do is you don't want to include the same code twice. So what it does is it defines this all caps mystr.h, and once it's included the second time, it's already defined. So the whole thing is not going to get copy-pasted.
Oh, where's it supposed to be defined?
No, like it's defined right there. So like the first time it runs, line 2 runs, and that's defined. Yeah. All right. See ya. Bye. It's gonna be 10. Yeah, I mean, I think so the point is separate here where so that's the thing that did pass within a lot of minutes is I hope